Alright, in this video I wanted to introduce the normal distribution. Okay, so what is a normal distribution? So a normal distribution is a type of continuous distribution. Last section or last test we dealt with discrete distributions. Now we're moving into the realm of continuous distributions. And so the normal distribution is the most popular one in statistics. Is that bell-shaped curve. Let's see if I can draw it here for you. Got a bell-shaped curve. And it turns out that the area, if we were to calculate the area underneath this bell-shaped curve, the area would be 1. So a normal distribution just in general, there could be several different normal distributions. But the most important one for us is going to be what's called the standard normal distribution. The standard normal distribution is basically a distribution of z-scores. But most importantly is that the mean is equal to 0 and the standard deviation is 1 of the standard normal distribution. So here are some graphs of some normal distributions. All right, see if I can zoom in here. So a property of, we'll get into properties in a second, but just some quick properties for you is that a normal distribution is a distribution where it has to be symmetric, first of all. So all of these normal distributions, the green, the red, and the black, they're all symmetric. Symmetric means that if you come and cut it right down the middle, the left side mirrors or looks the same as the right side. But what's different about all these curves, as you can see here, is the height and the location of the center. Well, those are directly related to those to that mean and standard deviation. The mean tells you the location of your the center of your normal distribution, and the standard deviation gives you an idea of the spread of your distributions. Maybe we should write that down. Mean gives you the center of the distribution, whereas the standard deviation gives you an idea of the spread of the distribution. Okay, so here they give us the actual theoretical formula for the normal distribution. Do not worry about that. We won't be dealing with that. But the most important thing about that you need to know about that formula is that we have both a part of the mean. So a mean is part of that distribution, and the standard deviation is an important part of that expression. As we said before, the mean tells you the center of your distribution. The standard deviation tells you the spread. All right, the properties, as we mentioned earlier, is that the normal distributions are symmetric. The mean, and because of this, the mean, median, mode are the same for a normal distribution. Total area underneath the curve is 1. So that's why in the next video we're going to talk about using the normal distribution to find probabilities. And the normal distributions are defined by 2 parameters. Those 2 parameters are the mean and the standard deviation. All right, the graph below shows the graphs of several normal distributions labeled A, B, and C on the same axis. Determine which normal distribution has the smallest standard deviation. So the smaller the standard deviation, the more densely packed the center is around the mean. That's because standard deviation tells you the spread of your data set. So in this case, if we're trying to talk about the smallest standard deviation, this is going to be the one that's skinnier, for lack of a better term. So if you look at all 3, A, B, and C, C has the smallest standard deviation because it is the skinnier, hence the taller, distribution on the graph. All right, same 3 graphs, but now the question becomes find the which normal distribution has the largest standard deviation. So it's the opposite of what we said before. So the smaller standard deviation means you're skinny and tall, whereas a larger distribution means that you're a little shorter and wider. So as you look at A, B, and C, really it boils down to either A or B. Well, A just seems to be wider than B is, so A has the largest standard deviation because this distribution is more spread out. All right, in this example, the graph below shows the graph of several normal distributions distinguished by their color. Order the standard deviation from least to greatest. So they want us to start off with a standard deviation that's the least between all three of these distributions. Well, from what we discussed before, the green graph has the smallest standard deviation because it's the more tightly compacted one with the taller density there. Followed by the blue graph, which means the red graph has the largest standard deviation because it's more spread. Oh, that's nice. They confirm what we just said. Okay, so as we said, there's a bunch of different normal distributions, but the most important one to us is the standard normal distribution. Okay, so we can standardize, meaning make it into a z-score, all normal distributions so they have a mean of 0 and a standard deviation of 1. This is called a standard normal distribution. And what I want to draw your attention to is this notation here that you're going to see a lot throughout these next few sections. Is here you see z, and you see that tilde? That means that z is approximated by or is represented by the n means normal. And anytime you speak of a normal distribution, you always have to specify those two parameters, the mean and the standard deviation. Okay, so here they're saying that z is approximated by a normal distribution where the mean is mu and the standard deviation is sigma. All right, and just to remind you, we talked about it before, but to remind you, the z-score, how do we calculate a z-score? A z-score is your data value minus the mean over the standard deviation. So make sure you remember that this symbol means mean. And the sigma means standard deviation. Next, we're going to talk about how do we basically find a z-score, is what this next example is going to be about. So for example, it says suppose that x, the random variable x, is modeled by a normal distribution where the mean is 17 and the standard deviation is 6. Remember we said before, they're telling us the mean is 17, standard deviation is 6. They're saying let x equal 5. So that's in our z-score formula, that's our data value. They're saying let x be 5. They want us to find and interpret the z-score of the standardized normal random variable. Okay, so what they mean is find the z-score for x equals 5, where the mean is 17 and the standard deviation is 6. So all we got to do, and I'll just use our solution here, all you have to do is apply our z-score formula, data value minus the mean over the standard deviation. So our data value, our x value is 5, minus the mean of 17, divided by 6. If you work that out, you end up with a negative 2. So that's the z-score. But the question also asks us to interpret what that z-score means. So if you remember back last exam, we spoke about how z-scores could be either negative or positive, or 0 for that matter. A z-score tells you how many standard deviations your data value is away from the mean. If that value is a negative, that means you're lying to the left or below the mean. If your z-score is positive, that means you lie above the mean or to the right of the mean. If your data value is 0, that means you are the exact same thing as the mean. So in our case, that negative 2 means that our data value, the z-score of negative 2, means our data value, which is the x equals 5, is 2 standard deviations to the left of our mean, or 2 standard deviations below our mean. Okay, here we go. They want us to find and interpret the z-score for the standardized normal random variable. So they tell us that x is 6, and they tell us that the mean is 4, and the standard deviation is a half. The mean is 4, standard deviation is a half. So here we go. The z-score equals our data value of, well, here I'll write the formula, x minus the mean over the standard deviation. So we're going to take 6 minus the mean of 4 and divide that by a half. Okay. So the z-score is 2 divided by a half. All right, and if you go to your calculator, take 2 divided by a half, you're going to end up with 4. right? Because remember, dividing by a half, you got to multiply by the reciprocal. Anyways, our z-score is a positive 4. And what that means is, because it's positive, what that means is that x equals 6, x equals 6, x equals 6 lies 4 standard deviations to the right of the mean. That's what that positive 4 means. A z-score tells you how many standard deviations are either to the left or to the right of the mean. All right, so we got Angelica. She's a tennis player who averages 6 aces per every game with a standard deviation of 2. Okay, so suppose the number of aces she gets every game is a normally distribution, and let x equals the number of aces per game. So then they're telling us that her aces per game follows a normal distribution where the mean is 6 and the standard deviation is 2. Suppose Angelica only gets 2 aces in her game. Find and interpret her z-score. Okay, so what they're telling us here is that, well, we know the mean is 6. We know her standard deviation is 2. We got that from the normal distribution. They told us that. And her data value is going to be 2. We're going to try to figure out her z-score for her getting 2 aces in a game. So here we go. The z-score equals the data value minus the mean over the standard deviation, which in Angelica's case will be 2 minus 6 divided by 2, which is a negative 4 over 2, which reduces to a negative 2. So what does this mean? This means that the z-score for Angela getting 2 aces lies 2 standard deviations to the left of the mean, or below. Left means below, right means above. Okay. So x equals 2, that was our data value. X equals 2 lies 2 standard deviations to the left of the mean. I'm sorry for my handwriting there. But so that means that was a subpar game for Angelica, right? That means that she's 2 standard deviations below her average aces per game. All right, so once we know how to get a z-score, we can also use that same z-score formula to find missing information. Let's get straight to an example. For example, if the z-score of 4 tells us that x equals negative 3, it's 4 standard deviations to the right of the mean. So z-score of a positive 4 means we are 4 standard deviations to the right of the mean. If the standard deviation is 2.5, what is the actual mean? So what they're saying is this. Go back to our formula. Z equals data value minus mean over standard deviation. We know the x value. We know the data value. It's a negative 3. We know the z-score. We know it's a positive 4. And we know the standard deviation is 2.5. The question is, what is the mean? That's what we're missing. So all you got to do is a little bit of algebra and solve this equation. So let's fill in what we know into our equation. 4 is equal to our data value, which is a negative 3, minus the mean, we don't know that, over the standard deviation of 2.5. Okay. We need to solve this for mu, the mean. So to get rid of the fraction on the right-hand side, we're going to multiply both sides of our equation by the denominator. Okay. So the left side, 4 times 2.5 is 10. On the right side, our denominator is going to cancel with the 2.5 we multiplied it by. Hence the reason why we did it. Negative 3 minus the mean. And now I'm going to add 3 to both sides. So 13 is equal to a negative mu. And then lastly, divide through by a negative 1. And I'm going to come over here. That means that our mean is equal to negative 13. Okay, so we just use our formula and solve for the missing information. Have one more example? I believe we do. All right, Barbara scores 3 goals on average for every soccer game. Suppose Barbara scores 5 goals in a game, and this value has a z-score of 1/2. What is her standard deviation? There we go. Once again, we're using our z-score formula. And we're just going to go ahead and fill in all the information that we have and solve for the unknown. So we know her z-score is a positive 1/2. 3 goals on average, so her mean is 3. Okay. Suppose Barbara scores 5 goals in the game. So her x value is 5 minus her mean of 3 over the unknown standard deviation. Okay. So we have 1/2 is equal to 5 minus 3 is 2 over the standard deviation. Okay. And to go from here, I'm going to multiply both sides of my equation by that standard deviation because I'm trying to get rid of any fractions. Okay, let me come up here. And so I have 1/2 times my standard deviation is equal to 2. Now all I have to do is either divide by 1/2 or I can multiply both sides by 2. It's the same thing really. I'm going to just multiply both sides by 2. And then we get our standard deviation is equal to 4. Our standard deviation is equal to 4. Okay, we got one more. Here we go. So the z-score of 3 tells us that an x value of 11 is 3 standard deviations to the right of the mean. If the standard deviation is 1.5, what is the mean? Okay, so let's just write down what we have. We have the z-score, which we know is 3. We have the data value, which we know is 11. And we have the standard deviation is 1.5. They're trying to help us. We need to find the mean, excuse me. So here we go. Once again, z-score, x minus mu over sigma. Now we just fill in the values that we know. So we know the z-score is 3. That equals our data value of 11 minus the unknown mean. That's what we have to solve for, over our standard deviation of 1.5. Okay. Multiply both sides of our equation by 1.5. Okay. So we get that 4.5 on the left side is equal to 11 minus the mean. Okay. We add our mean. I'm just going to go ahead and solve for this. Add our mean and subtract 4.5. You get that mean is equal to 11 minus 4.5, which is 6.5. Okay. So all I did there was I added my mu over and subtracted the 4.5. All right, well that completes this video. Hope this helps you guys out.